Hello. Okay, no longer on mute. Much better. Hi, as you said, I'm Mark Ramm, and I'm really privileged to be here and talk to you guys today. So I want to make the most of this time and try and tell you things that I think are valuable. I'm at Mark Ramm on Twitter. If you want to provide feedback as I go, feel free to tweet about that or whatever. Basically, about a year ago, I was at a talk by a guy named Steve Blank about startups and this and that and the other thing. And most of what he said I have forgotten. But sort of 3/4 of the way through the talk, I guess in the question and answer section, he was talking about writing 100-page business plan documents. And he said something that stuck with me. Not that I was writing 100-page business plan documents, but this sentence stuck with me. He said, "Your heart has only so many beats. Why are you wasting your time on that shit?" And I think that's a very important question. It's a good question to ask yourself sort of at any given time about whatever shit you happen to be wasting your time on. And it might be 100-page business plan documents, but it might be just writing software that people aren't ever going to use. So basically, I want to talk about how not to waste your life. Wasting your life is really annoying because you only got one of them, and when it's done, so don't waste your life. According to the internet, 9 out of 10 IT projects fail, and 9 out of 10 startups fail. According to Theodore Sturgeon, who is a science fiction writer, 90% of everything is shit. So it kind of makes sense, I guess. He actually said this. Somebody said, "Hey, I read a science fiction novel and it was crap." And his response was, "Well, of course, 90% of everything is shit." So I wanted to talk a little bit about, I'm ahead of myself. There are two different kinds of things that could be a total waste of your time in terms of, and now I'm talking to you guys as Python software developers. How many people here develop things in Python? Okay. I'm going to ask several questions. Probably lots of you will answer. Raise your hands. How many people write code for other people to use? Okay, lots of hands still. How many people write codes for other people outside of your organization to use? Okay, so less, but still a lot. I'm going to call that kind of thing products. That doesn't necessarily mean you sell them for money, but they're products that people somewhere else is going to use. 9 out of 10 projects fail. Some projects fail because of technical reasons. How many people have been in a software project that failed because people did bad things, technically? Okay, so like just me and like 30 other people. How many people have been on projects that failed because, well, you built it and then it turned out to be a bad idea? Okay, so slightly more people. How many people built it and it was crap and it was a bad idea? Okay, I've done this, so don't feel bad if that's you. So 9 out of 10 projects fail. Most of them actually, like this is a made-up number. Like the internet is crazy. Probably it's more like half. Like if you look at real statistics, but half is pretty awful. Like the idea that half of you, half of the time, well, half of you all of the time, or all of you half the time, whatever. A bunch of you people, a bunch of me, all of us spend our time failing. Like that sucks. Let's not do that. So there's two different ways that projects fail, which I already sort of alluded to. One, you screw up. Like you're a Python developer, you know what's going to be great is if I have, instead of using Python, let's just have everything written in I'm going to use Python as an interpreter for an XML programming language that I made up myself. Like if you make that kind of decision, then bad things are going to happen. I mean, I can't guarantee bad things, but the chances are very good. So the point being, we can make technical mistakes. Technical mistakes can cause problems. Like we could choose bad technology. I once worked on a project where everything was using Beeple. Beeple is the business process execution language. It is in fact a programming language written in XML. So that project did not do well technically. And also, we built something that nobody wanted. So it failed for both reasons. It was awesome. That was my sort of first big project as a full-time software developer after I had moved out of being system and network administrator. And I was like, yay, I get to be a programmer. Yay, I get to fail. So I like to not fail. So this whole talk is about helping you guys not fail. But the kind of failure I just talked about, technical failure, I'm not even going to talk to you guys about that at all. That's what the whole rest of this conference is about. Like, not teaching you how to fail technically. Ideally, those talks will not be about that. I haven't seen them yet. They're not to happen, but mostly they will teach you how not to fail, I hope. But I'm going to teach you about the other kind of failure, which is building stuff nobody wants. And we'll talk a little bit about technical failure along the way, maybe. But so I've built a lot of products over the last few years. I did some consulting. I worked for some companies. I worked on a bunch of products. All those products had someone who was like a product manager. Those product managers went out and they did market research. And they figured out what we should build, because then like lots of people will buy this shit, right? A lot of them did market research. Some of them did not do market research. They just pulled stuff out of their butt. Which one of those people won? Who did better? Anybody? The correct answer is it's a trick question. Both of them suck. And mostly they resulted in failure. So, like, I had this epiphany sometime, I don't know, like I got suckered into about 2 years ago into becoming a product manager. And mainly the way that happened is I was development lead on a project, and we kept building stuff, and we'd build stuff, and then nobody wanted it. And we're like, oh, that sucks. And then we'd do something else, and then nobody would want it. Or then we'd do something, and we'd get halfway through, and then like the product management people would be like, oh, maybe we should do this. So we'd change our mind and do that. And then we'd get halfway through that and do this, and like we weren't getting anything done, and it was terrible. And I'm like, I am totally wasting my life. This sucks. And so are all the other developers that work with me. And then, thank goodness, we had an event. This was at SourceForge. I'm probably telling stories out of school, but it's all public information. This dude bought 30% of the company, like, got rid of 4 people on the board, got rid of every senior manager person, like everybody VP level or above, all gone. The entire product management team, except one guy who'd been out of college for like 4 weeks. All of them got laid off. And so there was a bunch of job openings. And I was like, man, they're going to hire some new people, and they're going to be even less clued in than the last set of people, because they've been here for no time. So, like, I took the job just so that it wouldn't get taken by somebody who was really awful. And then, like, I could provide some shield to the developers, and they could actually get something done. This was my theory. But then I had this job, and I had to do it. And I didn't really like the choice of, like, going out and doing market research and being wrong, or making stuff up and being wrong. Like, I wanted to be right. And this was like crazy thoughts. So I was like, how can we do this? Let's try to apply the principles of science to product management. So I came up with this phrase, test-driven management. And my basic thinking here is like, okay, I've been a developer for a long time. When you have tests, you know you're making progress. When you don't have tests, you're just doing shit. Like, who knows whether it's better or not? Who knows whether it works or not? Like, you got no tests, you're writing code. That doesn't mean you're making progress, right? So I was like, hey, what if I try to use this idea that tests equal progress as a manager, not just as a developer? So one of the things that we did while I was at SourceForge is we started out, the first thing I did, very first thing I did when I started working on SourceForge is I was given tasks to redesign or implement a redesign of the project summary page. So here's Angry IP Scanner. It's got a description, it's got a screenshot, and now it's got a big green download button. Before this, no big green download button. Just to click to view all files, and then there'd be this list of all the files that had ever been released for this project, and you'd have to find it and download it. So we added the green download button. It made things better. People liked it. It worked. So then, a year and a half later, we redesigned everything to look like this bottom one. It's got Angry IP Scanner. It's got the description, the screenshot at the bottom. It's sort of like a clearer, little 9x9 grid of information. And then eventually we redesigned it this way. So of these three, which one is the best? Who thinks the first one is the best? Who thinks the second one is the best? Okay, one person. Who thinks the third one is the best? Okay, so I'm going to tell you, the first one was better than the one that came before, but it is not the best. The second one was not as good as the first one. And the third one was better. How do I know this? Because I ran tests. That is how I know. Empirically, you can say visually one looks better than the other, which one seems easier to see. But when you actually put these things in front of users and run tests, you can see which people get the file they want more often. And it turns out that going from this one to this one, there was something like 20% increase in the number of people who get the file that they want. Now there's reasons for this, and I'm going to talk about those in a little bit, but we did tests. And we found out that people click the download button, they find the download they want more often with this page than they did with the one that came before. What is really crazy is the first two times we did this, we didn't test. We didn't know what was better. We didn't know if things were getting better or worse. We had people, they're making designs, we're pushing them. We don't know what's working, what's not working. So my fundamental assertion in terms of deciding what to do, what features to add, how to build products, is tests are how you know you're making progress. If you don't have tests, you don't know shit. That's just the way it is. Developers figured this out a long time ago. I mean, if you haven't figured this out in the development side, then maybe you're looking toward the first kind of project failure. But on the product side, this is still true. But what do I mean by tests in this case? I mean experiments. So anybody, I'm going to talk about I'm talking about scientific product management. Anybody want to explain how science works? Somebody? This guy. He does. Okay, someone else. He does.
Science, what is it?
And
skeptically querying the world to see how it works. How's that?
That's a... Oh, he's got a...
Up the back.
What does this guy say? Give it a shot.
I say formulate the hypothesis and design an experiment to test the hypothesis.
That is a good question. Both of those are important. So I'm going to talk about both of those things, actually. They're key things. So my question was, what if product managers documented their assumptions? What if product managers worked with the team to learn about what works and what doesn't work? And what if product managers didn't just make shit up? What kind of a world would that be? And my assertion is it would be a better world. So here's a very simplified version of the scientific method. You ask a question, you might go out and do some background research and say, have other people asked this question? Did they get an answer? Did they do some experiments? What's happened so far? If you don't do that part and you don't know what electricity is, then you could do research, but you probably end up like Ben Franklin putting a kite up in the sky and electrocuting the crap out of yourself instead of getting some good results. Not to say bad things about Ben Franklin, but if you did that experiment now, it's because you're stupid. Construct a hypothesis. So you want to say, like, this is the way I think things work. And then you want to test your hypothesis by doing an experiment. Then you want to analyze your data, draw a conclusion, and report your results. Now, what if you did this sort of thing in product management? What if you said, hey, like, I think people are going to like this second version better than the first version because it's a lot simpler. It's a lot less clutter. It's very obvious what you click. Like, it doesn't have this big weird, whatever that divider bar at the top is. Like, that looks weird. Like, I don't like it. Like, I think the second one is just cleaner. Like, people will like it better. So you could make this assertion. Then you could say, well, let me do a test. Do people like it better? But better would be, like, I think people will like this better because X, Y, and Z, and test X, Y, and Z. The more detailed your assertion can be, the more you can test out of it. You can say, people will like this better because this download button with the SourceForge logo is more obvious than that download button which has no logo. Like, they can understand the difference between these download buttons. Or whatever your assertion is. And then you can test just that one little piece. You don't have to test a whole page redesign to figure out which of those things is better, whether your assumption is right. So you construct a hypothesis. You test your hypothesis by doing an experiment. There's an important thing here. Karl Popper, who's a philosopher of science, among other things, came up with the idea of falsifiability. Science doesn't prove that something is true, but it doesn't do anything unless you state a hypothesis that is falsifiable, that there's some way to do an experiment. When you do that experiment, you could figure out that you were wrong. It's not so much about figuring out that you're right as figuring out that you're not wrong yet. Here's a Karl Popper quote, actually. He's talking about science and history, but he says, "We both start from myths, from traditional prejudice beset with error, and from these we proceed by criticism, by the critical elimination of errors." So back to your point. The role of evidence in the main is to correct our mistakes, our prejudices, our tentative theories, that is, to play a part in the critical discussion in the elimination of error. So the point here is not that you're ever going to find the truth, necessarily. You may not know exactly what people want. Like, people are weird, and we'll get to people are weird in a second. But you may not ever find the exact nature of what people want. What you're going to find is what people don't want, that your assumptions about what people want or thought were wrong. And having the ability to go to evidence and make those decisions is a lot better. If I go back to this, there were huge arguments by people at SourceForge about which of these things was better. Certain people worked really hard on the first one and thought the second one was terrible. Other people designed the second one and thought the first one was terrible. People thought the third one was not any better. Like, different people had different opinions. Arguing about your opinion about which is better is annoying and stupid and a waste of time. Do not spend your life on that shit. Do a test, get some evidence, make some decisions based on actual evidence. Then, like, it's not you. Like, I'm not the product manager being like, hey, like this, like, I'm not saying, like, not that I thought this, but say I was a product manager, I could say, that is ugly and I hate it. This is way more pretty, and this is what we should do. If I am, as product manager, making these decisions, then people are going to be pissed at me because I'm just arbitrarily saying stuff, and they don't believe me. Whether I'm right or not makes no difference. Like, if I'm not relying on data, on facts, then how do they know? So, what kind of tests, I went too far, do we want to run? So I stole this from Dave McClure, so I didn't make up R, but this is nice and easy to remember. This is metrics for pirates, and can everybody say the acronym here? R. So the kind of things that you want to measure are, and okay, but R. Okay, before I go into this, like, I'm just going to admit, like, I'm a web person. It's like 2012. I assume most people are doing web things or things that are connected to the web. So a lot of how you measure this that I'm going to describe, I'm talking about web stuff. That doesn't mean you can't do it if you're not doing the web, but you know, if you're not doing the web, I don't know, like maybe it's 2008 for you, or 1998 or 1988, I don't know, but like you're gonna have to translate in your own minds or come up to me afterwards and ask me questions, because I just don't even know how to think in the not web world anymore, unfortunately. The internet has invaded my brain. So the first kind of metric, and I'm not going to talk in a lot of detail about all of these. The slides I'll put up. You can also look up Dave McClure's presentation on this. But acquisition, how do you get users into your site? And whether your site is like a web application or it's just a site that sells the thing that you do offline, like all of this is still true. You want to try and get people from search engine optimization or search engine marketing or social networks or widgets that you install in Facebook or whatever, PR, campaigns, television ads, whatever way you're trying to get people into your site, you want to measure this stuff. Like not measuring this means you don't know what works at all. And if you're not actually successfully getting users in, like if you don't have something that people want and will come to and look at, then like building the next step which is the actual thing, is kind of not valuable. And you can test this before you build the product. You can build a website with a homepage that says, hey, wouldn't it be awesome if I could solve all of your problems with hemorrhoids by blah, blah, blah. And if you advertise it and people are like, yes, I have hemorrhoid problems and I would totally pay to have them fixed. Then you know that maybe your miracle hemorrhoid cure website, I don't know how you're going to write a web application to cure hemorrhoids, but some of you all probably can do it because you're way smarter than me. You're like, dude, I got it. But if you write a web application cures hemorrhoids, you can see, like, okay, people would buy this, or they would at least be interested, right? So you can start measuring activation before you even build the product. Or that was acquisition. Now activation. Activation is, okay, they come to they get to your hemorrhoid cure miracle website, and then they're like, yes, buy the hemorrhoid cure. I have hemorrhoids. They hurt right now. Please fix them. I will pay $10. I totally will pay $10. And you could even test prices, like I would pay $100. Like, dang, hemorrhoids. However, like whatever the thing is, like you figure out, like, do they click the button that says that they would actually become a buyer? Then retention. Retention really works for web applications. If it's hemorrhoid medication, I guess you want to know if they keep signing up. Like if they keep getting new shipments every month, great. If they're like, hey, it didn't work, and they hate you, then they're not going to buy more. You're not going to keep selling it. It's not going to work great. Referrals, like, would people recommend this? There's a metric called the Net Promoter Score, which is really useful because people do not want to recommend your product if it's shit. Like if they're like, hey, that is crap, they're not going to tell their friends, go get this crap, because it makes them look bad, and people do not want to look bad. So this, like they might not tell you, if you go up and you be like, hey, is my product crap? They might be like, no, it's great, we love you. But they think it's crap. They're just being nice. But they're not going to be so nice that they tell your friends that your crap product is good, because their friends are going to hate them, and they don't want that. So they might lie to you, but they're not going to lie to their friends. I mean, anyway. So they're not going to refer your crap product to their friends because that makes their friends unhappy. It lies to their friends in a way that makes their friends mad at them. So knowing whether people will refer your product is actually the best way of knowing whether they actually like it or not. Although some people may not refer your hemorrhoid website just because they're embarrassed about it. Like, I don't know. So there are other things that you could be looking into, hypotheses you could test in various ways. Ooh. Then you can test like revenue, are people willing to pay for your solution, etc. So next I want to, so I talked about all of this as though it makes sense and is clear. Like you have a product, you're just trying to optimize how much people will do. or whether people will buy it or figure out a few things about it. And that's what we might call normal science or like normal process. But if you're a startup, there's a lot of questions where you don't even know whether it's even possible or not. Like Zappos. When Zappos started, there was a real question, at least in my mind, will people ever buy shoes on the internet? Because the key thing about buying shoes is trying them on and seeing if they are comfortable. Because shoes that hurt are no fun. Zappos people, they're like, we're going to sell shoes on the internet. And I'm like, have you guys heard of pets.com? Like, people won't buy pet food on the internet. Why would they buy shoes? Doesn't make sense. Turns out, I'm totally wrong. I'm an idiot. People, for whatever reason, are like, my pet, I can't buy their food on the internet. But my feet, totally fine with shoes I get from the internet. Like, who knows? People are weird. But the Zappos people, like, they could have done what Pets.com did and build warehouses, stock them full of stuff, build this whole order processing system, build a whole system to sell shoes on the internet, and then go and test whether people will buy shoes on the internet. That would be dumb. That is not what they did. What they did is they went out to shoe stores and took pictures of shoes that were available for sale in shoe stores. And then they went and they put up a website and said, hey, do you want to buy shoes? And when people said, yes, I want to buy shoes, they went out to the shoe store, like there was a dude, and somebody clicks on a button on the internet, and the dude's like, uh-oh, and he goes and runs, and he's like, I bought shoes at the shoe store, and then he comes and runs to the UPS, and he's like, now I put it in there. And there's like just a dude buying shoes at shoe stores and shipping them.
But it worked.
It worked. And they were like, people will buy shoes on the internet because they don't care if they hurt, they care if they look good. And I was like, so those people are not me, obviously. Like, I do not go out and buy nice high heel shoes on Zappos. But they also figured out like that they had to have a return policy that made sense, and then people would feel a lot safer buying shoes. And they actually like made a huge thing about their return policy and their customer service to overcome the objection of like, what if the shoes don't fit? And they figured out how to make it all work before they spent money, which is awesome. Like, because then they're not wasting their time. They don't have hundreds of people wasting their lives on something that's not going to work. So, the traditional way to build a great product is you start with a great idea, you build a solid implementation, you launch with great marketing, and then you win, unless you don't. And Pets.com is a super prime example, but there are a million examples. Like, Apple created the Newton. It didn't work at all. And it was probably a great idea. I mean, everybody has PDAs now. The implementation, like, it was the best thing around that did that at the time. They had a lot of marketing, they were Apple, and yet nobody bought them. So it's not just having a great idea, having a great implementation. You have to have something that fits with a user perceived need at the time. So you may not win. In fact, 9 out of 10 startups fail. That's actually an underestimation. Depends on what you mean by fail, but most of them do not succeed. Startups fail even more often than regular companies. And I want to bring this back to science. There's a book. Does anybody know The Structure of Scientific Revolutions? All right. There's a few people who know about this book. Does anybody know the phrase paradigm shift? Okay. Paradigm shift comes from this book. The fact that marketing droids and other crazy people said paradigm shift like 1,000 more times than they should have said it after this book is not this book's fault. This book is a very good book. I highly recommend it. And it talks about the difference between normal science and scientific revolutions. Normal science is like what goes on most of the time in science. People are like, hey, we pretty much accept the current quantum mechanical theory, and we just want to figure out, like, does the Higgs boson particle actually exist? It's predicted to exist. Let's do an experiment to see if it does. Let's test it. Like, it's all good. Like, that is normal science. It's like, we have a theory of how everything works. Let's test the edges of that theory and see if the pieces all actually do fit. And then let's come up with, when they sort of only fit a little, let's come up with explanations for why they don't quite fit that make sense. And sometimes these explanations can be weird. Like if you read Isaac Newton, he has explanations for why the speed of sound is exactly the speed that it is, and those explanations are crazy. But they seemed not crazy to him. They just seem crazy to us now because we know more shit. And then there's these events that happen in science that he calls scientific revolutions. They happen in every field of science. They happen every once in a while, where somebody takes the whole paradigm, the whole set of rules by which the universe works, and says, you know what? It was wrong. Like, Newton had this whole theory about how gravity worked. Einstein says, not so much. Turns out gravity is not what he thought, and this formula, let's think, what if we thought of gravity as like sort of bending space-time instead of as like a force, that like a traditional Newtonian explanation of gravity? Like, that's crazy thinking. But it re-explained all of the data that was currently available in a better way, and people did it. This is what startups do when they're doing something interesting. I mean, there's lots of startups that are like, hey, I'm going to, be like Salesforce.com, but for dentists. That is not an interesting startup. That is anyway. Those startups, like there's a book called The Lean Startup. It talks about optimization versus discovery. But it's the same difference between normal science and scientific revolutions. In a scientific revolution, you're coming up with a new system about how people think and work and whatnot. Like the iPhone was a revolution in that it put together PDA, media player, all of that thing in one device, and people actually wanted it because it was cool. They did something that nobody else was doing. They did it in a new way, and they found a very large audience. That's what startups can do when they're interesting. This comes from a guy, remember I mentioned I was at a Steve Blank talk way back at the beginning? Steve Blank is my hero. He wrote a book called The 4 Steps to Epiphany, in which he said, let's not do product development, let's do customer development. Instead of saying, let's develop a product and then see if we can get customers, he said, let's get customers and then see if we can build them a product. Crazy, but it works. Like, and if you do it this way, this part where you iterate, like, can I find customers? Can I find customers who are willing to buy this thing? Oh, are they really willing to buy it? You can iterate on that without spending hardly any money. And then once you've figured out, yes, like I have a cure for cancer, people will pay me for it. Then you can build the product. Like now, I have to actually cure cancer. That might be the hard part, but it might be the easy part. Like sometimes there's a problem that is really easy to solve and nobody has solved it yet because they just didn't think of it. So I'm going to skip a couple of slides. So the thing with product development is, or customer development is, you've got to find people who are willing to pay. Sometimes there are different hard problems. There's like, is this product desirable? Like a cure for cancer, you probably don't need spend a lot of time testing, is that desirable? You're pretty sure if you figured it out, people would buy that shit. Is it feasible? That is actually hard for curing cancer. Is it viable? Will people pay at a rate that makes it affordable? That depends how feasible it is. Like, what you should be doing as a product manager or as an engineer who cares about product is figuring out which of these things has the biggest risk for the particular thing you're working on and solve the riskiest problems first. If you are 90% sure that you have a cure for cancer and you're just like, is there a business model that will work? Find somebody to help test that. If you're like 10% sure you can cure cancer, maybe spending a lot of time figuring out how much people will pay for a cure of cancer is premature. So I'm going to skip a few. So you could say, is this product desirable? So what this is it's fake stained underwear that you store money in when you travel. Like, This is a product idea. Is it a good one? Is it a bad one? I don't know. You might like go through the process of trying to discover some customs. Like, is there a problem? Like, yes, people get their money stolen on travel. Like, here's my proposed product. I'm going to get some regular underwear. I'm going to take some brown marker and put some fake stains on it. I'm going to try and sell this to people. I'm going to see if people will buy it. I'll do some search engine advertising, see if like I can actually get customers. Like, you could use this whole product development strategy on the stained underwear product and figure out, does this work? Once you figured out, yes, people will in fact buy this. And by the way, this picture comes from Amazon.com. You can buy this product right now. If you are out there wondering, like, did he just make this up? No. This is an actual product I found while searching for like money belts and whatnot on Amazon.com. Like, you can do this. And if you travel a lot and you need stained underwear, pre-stained, you don't even have to add your own stains. Like, this is the shit. All right, so I guess I'm going to leave with one more Karl Popper quote. He says, "Great scientists are men of bold ideas, but highly critical of their own ideas. They try to find whether their ideas are right by trying first to find whether they are not perhaps wrong." Like, he's a philosopher, so he says not perhaps wrong. He means stupid or bullshit. And my proposal is that this is, like, you could cross out great scientists and say great product managers. And this would be exactly true of product management. It would be exactly true of how not to waste your life doing stupid shit. Like, test your ideas. Come up with a crazy idea. Like, if you actually think you can cure cancer, like, great, test that. If you think you can, like, solve problems with the way people buy, well, I'm not going to come up with all the product ideas, but like, I think we are doing great things at Canonical. I think Juju is very interesting. One of the things that I'm very interested to do is test this and go talk to people who are actually using it, make sure that my understanding of what people need and what we are building match up, make sure that the open source product we're creating and the need in the community fit correctly. Like, this is the job that you should be doing so that you know that what you're building is not a waste of time. Because your heart has only so many beats. So, with that, I'll answer questions.
So, people over in Hall 3, if you have questions, don't raise your hand. Walk to the back of the room and form a queue there. And I will bring the mic over there so that we can ask questions there.
Okay, maintaining the tradition of PyCon. Okay, I completely agree. Fantastic talk. One of the issues, though, is there's a big difference between data and knowledge. It's easy to do experiments. You can do experiments, but there's no point if the experiment is completely wrong. So, for taking a practical example, you were looking at your download page for SourceForge. Your experiment, you could say, okay, my experimental method for determining whether this page works is how many people visit this page, click on the download button. And that sounds, on first approximation, a reasonable kind of metric for whether or not the page is working. But if you redesign the page and people don't click on the download button because it enables them to discover that this is the wrong package easier, then your metric is going to go down even though the page is actually more successful, but the actual problem is the fact the search page is returning the wrong results. So, have you got any comments on how do you establish that you're actually doing the right experiment in the first place so that you don't end up doing lots and lots of data pointing you in completely the wrong direction?
So that is a very, very good question, and that is exactly the problem with science. How do you figure out that you're doing the right experiment? And the way you do that is, like, you try to be smart. Like, you try to eliminate variables. So, like, we go to, say, we know people like VLC on SourceForge. Most people come to download VLC from the VLC page, not from our search result page. We know those people really, really want to download VLC because they were on the VLC page, then they come to the SourceForge page, and then they want to download it, right? So those people are highly unlikely to think that this is the wrong page. Maybe we test with just them, and we eliminate all of the other traffic for the purpose of this test. this actually is a much more difficult question than even his question realized, because one of the things that this page does also is show ads. When people get the download faster, they spend less time looking at ads. They click on the ads less. We make less money. So there's another whole trade-off that we need to think through, like getting people the thing that they want the fastest that they can also cost us a lot of money. So how do we deal with this, and how do we balance all of these things? Like, sometimes as you go deeper and deeper, you have more and more experiments that you have to do to test your hypothesis. Like, my assumption was that the faster people get to the download page, which has a lot of ads, the more money we'll make, because we'll get more people to that page, and that page monetizes like 10 or 20 times as well as the project summary page. And we did a test, and that actually mostly bared out to be true. But designing experiments well is the hard work of product management, in my opinion. Other questions?
Next question.
Hi. So with SourceForge, you obviously have a lot of traffic going to it, and Canonical and a whole bunch of other places. Have you got any tips for people that are really, really just starting out, getting that traffic so you can actually test? Like, if you don't get any hits at all, you can't test. So it's a little bit off topic, but kind of.
Right.
Yeah.
Well, no, that's not off topic at all, I don't think. Like, my first set of tests that you do are around acquiring customers or visitors to your site. Like, and that is hard work. Sometimes you do marketing on related, like, forums. Sometimes you do marketing, like you do search engine marketing. You pay for search clicks. Whatever you have to do to get a few clicks. And you don't need a ton when you're just getting started, because chances are, like, you need a big sample size if you want to know the difference between a 2% conversion rate and a 3% conversion rate. But if you have 100 people show up your website and none of them want to buy your product, that is the most likely result that you're going to get when you're just starting out, is that you were totally wrong and it's not going to work at all. So buying 100 clicks is not so expensive. And then you can figure out, uh-oh, we are totally off base, let's rethink this. And it's totally worth it, because then you're not wasting weeks of your life building a thing that nobody wants. So sometimes you buy clicks, sometimes you have to figure out other ways. And it really depends on your product. Like, I have a friend who, like, sells patterns for needlework stuff on her blog. And she uses a lot of these techniques. And you don't need a lot of traffic. You just need to get the ideas figured out. And then you can, like, with the traffic you have, a lot of times small changes make big enough differences that even small amounts of traffic, you can see a statistically significant result.
Okay, I think we're going to have to make this the last one.
I guess it's, excuse me, related to the last question. We do testing. Obviously, you need to test long enough for it to be statistically significant, and we have trouble kind of explaining to some of the less technical people that you need to run it for, not just a day or not just some hours, but days and weeks to be able to find that it's statistically significant. Do you have any advice on, explaining that to people who don't really understand the scientific method as well as, some of the other people?
I guess I have a couple of pieces of advice, one of which is kind of just me being a jackass, which is, like, if people don't get it, maybe try and find a place to work where people are not stupid. It might be harder than it seems, but that's my jackass answer. My other answer is, like, trying to explain science to people who don't get science is hard. Especially if they've already grown up to adulthood and somehow gone through school without ever figuring this out. Also, if you're not in the optimization phase, if you're still in the discovery phase, a lot of times you get to a significant result quickly, or else it doesn't matter what is statistically significant. if you're showing like a 2% difference between two options and you still don't know whether you have a working business model, 2% difference is not going to make the difference between this business model survives or it doesn't. So the test already showed you what you need to know, which is it doesn't matter. Whereas if it's like 80% different, the test showed you what you need to know, which is that it does matter. And it showed you that in a much quicker time because you don't need to know that it's 80%. You need to know that it's a lot better. So sometimes statistically significant is less strenuous than you thought. And that they were actually righter than you, even though they don't understand. Which just goes back to the whole point, like you gotta test your own assumptions. And I think my time is up. I will answer questions in the hallway or whatever afterwards. And thank you all very much. It's been a privilege.
Thank you for presenting your talk, Mark. As a token of thanks, we have our standard speaker's gift of a PyCon Australia 2012 coffee cup, a 250-gram bag of our bespoke coffee blend, African Swallow, and a 500ml bottle of cask-strength single malt Tasmanian whiskey, courtesy of the Lark Distillery.
Where are you?